Today I will be going over version 0.1 of Astryx Engine, which is a custom C++ engine made with OpenGL. I kind of just started it because I figured, I want to go deep into C++, and I thought it'd be a fun project. And if you would like to check out the GitHub for it, the link will be in the description below. So I just want to talk about the core philosophy of my engine first, which is this idea of, if you look at the main right now, it's just including the application file, just creating an instance called app, and then just calling the app.run function, and this is just a simple initialization error handler. It is nothing more. All main is, it's just the startup thing. It's just the setup. Everything else is like a modular subsystem. That it's like a system. So we have the movement system, and the camera system, and the render system, and then later we'll have the lighting system, and the ECS system, and physics system, etc., etc. So I'm just going to now go through each file, section area, and just kind of explain what they are. So this, like I said before, this is the main.cpp. It's nothing more than just creating an app, doing a little error check, calling the run function, and then returning 0. That's all it does, because it's just the startup point. And then we can start taking a look at the core function. So we have the application. This does things like the mouse callback function. I'll probably move that somewhere else eventually. GLFW initialization. It's just like initializing stuff. Initializing input, assigning cameras, this is loading the models and attaching a texture. The render function, which is like binding textures and cubes, for example. And then the run, which is calculating delta time, get frame buffers, handling the input, and then rendering. Pretty simple. Input, this I use a std bitset because it's of one time, which is very efficient. And simply just because of how GLFW works, it can store each key press as like a true false, and then just does the necessary action when that key is pressed. And then logging, because std_cout is slow, I included I made a dedicated little logger. So simply we can go to main, for example, and we can just call log info, and then what's eventually going to happen, it's just going to be log, it'll print info engine initialized, kind of something like that, in the console. That way I don't have to manually put std_cout everywhere, because that's really slow, and it's also just cleaner. Now moving on to the rendering, which is the big part of version 0.1. We can start off with camera, which, as we can see here, it handles mouse and WASD movement. Like, this is all the camera movement. This is mouse. This is like the actual camera function. This is the mouse movement using yaw and pitch. And then just the GLM matrix math with the view matrix. We can move on to mesh, which okay, wait, what is this? This binds like the VPO and the VAO. gets the vertex count, and then sets the position and texture pointers. And then finally we can, two more. We have a shader, which reads the file. This is just a little error handler. And then compiles the shader right here with GL compile shader. And attaches it to our frag and vert shaders right here. Sorry if I'm going a little slow. I haven't looked at this for a minute, so because I've been working on the other stuff. So, index the program, yeah. And this is just for loading the texture, and it uses STB to flip it, and it uses STB to load it. Yeah, this is the important line. There's a duplicate of that, and I don't need that. It should work fine. Yeah. And then lastly, we have renver, which I skipped over by accident. This is actually fairly simple because everything else is in its own little system. So this is just the color bits, and then giving the matrices, which like embedding. So like the model view rejection, the shader.use function, and have the same thing here, and then draws the shader. All right, and then we can move on to the model loader and the scene file. So model loader, this one's actually pretty cool. So we use fstream and sstream to parse each file, and then parsing the vertices by removing the slash and making it a a space with this. And then this is inputting them, and I had to input the normals because otherwise when I showed the dem, it was just like acting where the UVs would map incorrectly. And then these are each of the coordinates and pushing them to the vector of each corner of the triangle, which is why all the models, if you look at the latest release, they need to be triangulated. And then lastly, for the transform, this is the model matrice, and we're just giving it a transform component to the game object, and then this is just using the model matrix. We use we are going to do a live demo of the project. So as we can see here, okay, yeah, weird. So we have a normal cube right here. We have a slowly spinning cube, and then a fast spinning cube. Whoa. Okay, that's trippy. I'm gonna get out of here now. That's what we have so far, and then I'll actually go ahead and show you what it's like to add a different cube. Add another cube. So we go to application. Well, first we need to go to application.h. Get another one. Get mcube4. give it a new pointer, and then we go here, and basically it's all going to be the same stuff, except we need the numbers, obviously. Then here's what we'll do. We'll do this. I'll shift over to 8, and then this will just be a standard cube. So it'll be just unfortunately it is not hot reload. You need to rebuild it every time, but I think that should be fine. So now we have another cube. Nice. And then if we go and look at the README, we can go ahead and see these are the big things I want to bring in next. So I want to integrate with a simp, add like lighting and point lights, shadows, basic ones. We're not going to go crazy. We're not going to do race tracing or any of that crap because that's a rabbit hole that I don't want to go down. And add basic IMG UI so that we can get this stuff actually shown on the screen. But yeah, guys, thanks for watching, and I'll see you in the next video.